everyone. In this video we want to use mesh analysis to find the mesh current in each of the loops in this particular diagram and the nodal voltages too. Okay, now remember from our previous lessons that the only difference between mesh analysis and Kirchhoff's rule is that whenever a resistor is in between two mesh currents, the current passing through that resistor is seen to be the subtraction, the difference of the mesh currents. Like for example, now I1 is in between a 1 ohm resistor is in between I1 and I2. So the current passing through the I1 1 ohm resistor is I1 minus I2 or I2 minus I1 depending on the direction. In the same way, look at this 3 ohm resistor here. The current passing through the 3 ohm resistor is I3 minus I4 or I4 minus I3 depending on the direction. Okay, so we continue. We take loop 1, that's for I1. I hope you have your biro with you. Now, if you consider loop 1, you will see that using this formula, that the total EMF is equal to the total IR. You can see that the loop here, look at the direction, is going from plus. The total EMF here is going from plus to negative. That means higher potential to lower potential. That's going to be minus 8. Okay, equal to, now for I1, the current, you are going to have your 1 ohm resistor. The current passing through 1 ohm resistor. In this case, since we are dealing with mesh 1, is I1 minus I2. But if you are dealing with mesh 2, it will be I2 minus I1. Okay, so plus the other resistor there is 2 ohms. Okay, and in this case, the current passing through it is I1 minus I3. Okay, since we are dealing with I1, if we open up that, we are going to get minus 8. Okay, is equal to I1 minus I2 plus 2I1 minus 2I3, and that means minus 8 is equal to I1 plus 2, okay, 3I1, because I1 plus 2I1 is 3, then minus I2, minus I2, then minus 2I3. Okay, so you can write that somewhere, that minus 8 is equal to 3I1 minus I2 minus 2I3. Okay, that is it for loop 1. So let's see for loop 2. Now, if you consider loop 2, there is no voltage source in loop 2. So that means considering loop 2, there is no voltage source there, so that is 0, equal to the 1 ohm resistor there. The current passing through the 1 ohm resistor there, in this case, is I2 minus I1. Okay, then we have plus the 6 ohm resistor. The current passing through that is only I2, just I2 passes through the 6 ohm resistor. Then the 4 ohm resistor, which is 4, you have I2 minus I4. Now, when we open up that bracket, now we are going to get 0 equal to I2 minus I1 plus 6I2 plus 4I2 minus 4I4. Okay, so if we collect like terms, you're going to get 0 equal to minus I1, then plus 11I2 minus 4I4. Okay, so that gives us our equation 2. You can write that down somewhere. Minus I1 plus 11I2 minus 4I4 all equal to 0. Okay, this is I4. Now we continue with the third one, the third loop. Now you can see that the current through the I3, your I3 here is 4 amperes. How do I know? That's the only current in this loop, and that's the current source reading 4 amperes. That is definitely I3. And that's the same way with I4. I4 here we can say is minus 8 amperes. Minus 8 amperes is the same thing It is minus 8 amperes because the direction of the loop is opposite the direction of the current source here. So we have it as minus 8. Now with this, we can be able to find our I2 and our I1. Okay. Now considering I2, the second equation we just wrote down now, we said that 0 is equal to minus I1 plus 11 I2 then minus 4 I4. Now if we substitute values now, we are going to get 0 equal to minus I1 plus 11 I2. Your I2 is what? Okay, we don't know what I2 is yet, so we just write it as I2 then minus 4 times I4. Our I4 here is minus 8. Okay, so we're going to get 0 equal to minus I1 plus 11 I2 plus 32. Okay, which we can still write as bringing this to the other side of the equation. We can have I1 minus 11 I2 is equal to 32. You can call that equation 4. You can write that down somewhere, that I1 minus 11 I2 is equal to 32. Now let's see the equation from loop 1. Now from loop 1, the equation we had from loop 1 is that minus 8 is equal to 3I1 minus I2 then minus 2I3. Okay, if we substitute the value for I3, we'll get minus 8 equal to 3 I1 minus I2, then minus 2 times I3, like we saw here, is 4. So we are going to get minus 8 is equal to 3 I1 minus I2 minus 8. Okay, so we can see that 3 I1 minus I2 is equal to 0 when you bring this to the other side, minus 8 to the other side, and that means 3 I1 is equal to I2. So you can write that down somewhere. So I1 I2 is the same thing as 3 I1. Okay, so since we already have from the last equation that I1 minus 11 I2 is equal to 32, I1 minus 11 I2 is equal to 32, and now your I2 is 3 I1, so we can say I1 minus 11 times 3 I1. Okay, this times 3 I1 equal to 32, and that will give us I1 minus 32 I1 33, sorry, equal to 32. So that will be minus 32 I1 is equal to 32. So you can see that your I1 here is equal to minus 1 amperes. Minus 1 amperes. So with that we can find I2. I2 is 3 I1. So we can say that I2 is equal to 3 times minus 1 ampere. So that will give us minus 3 amperes. So you can write that down. We can see that our I1 is minus 1 amperes. Our I2 is minus 3 amperes. Our I3 is 4 amperes, and our I4 is minus 8 amperes. Now let's find the current now through each of the resistors. For the 1 ohm resistors here, the current passing through it is I1 minus I2 or I2 minus I1, like we said, depending on the greater direction. So our I1 here is minus 1 and our I2 is minus 3, so we have minus 1 minus 3. Okay, so that's giving us minus 4 amperes. That is for that. The current passing through the 6 ohm resistor is I2 already. Then we already know the current passing through this 4 ohm resistor is I2 minus I4. So we have I2 minus I4, or you say I4 minus I2. They're the same. Your I2 is minus 3. Then minus your I4. Your I4 is minus 8. Okay. So that is going to give us minus 3 plus 8, which is equal to 5 amperes. Now the current passing through this 3 ohm resistor here is I3 minus I4. Okay, so which is 4 minus 8, and that is going to give us 11 amperes. Okay, sorry, that's 12, not 11. That's 12 amperes. Let's rub this off. Okay, so and the current passing through this 2 ohm resistor here is I1 minus I3. I1 minus I3. Our I1 is minus 1, then minus I3 is 4, so that gives us minus 5 amperes. Okay, so this is exactly what we have. And so with that we can find the node voltages. You can see that V1 is the voltage across the 1 ohm resistor. Let me make that clear. Here you can see that V1 is the voltage across the 1 ohm resistor. So you can say, okay, the 1 ohm resistor is between V1 and V3. So we can have it that V1 minus V3, maybe the current passing through the 1 ohm resistor I should be equal to V1 minus V3 all over the resistance R. Okay,